All right, welcome to EE391 MM391 Engineering Economics. Well, the full name of the course is Maintenance, Reliability and Engineering Economics. And we are doing this part of the course which is to do with engineering economics. Welcome again. I hope you have had a refreshing weekend. Before you move on, I've just put an announcement into the chat box. If you could please enter your full name and student ID into the chat box so that I have a record of who is present here this afternoon and who's missing for the purpose of our particular assignments and so forth. Let's now start off our lecture. Let's now start off our lecture proper. Um, we are. Let's now start off our lecture proper. I would like to share the screen. I would like to share the screen. Okay, guys, if somebody could quickly give me some feedback as to if you are able to see the Microsoft Word document on the screen.
Yes, sir.
All right, thank you. All right, so let's just do a quick recap of the topic which we were covering last week. We were covering a
Yes, sir.
topic called equivalence, and it says there's two cash flow diagrams, one on the left and one on the right hand side, right? So the one on the left, or the first two periods, this guy pays $100 each. The person puts in $200 each, and the period 3, period 4, period 5, interval 3, interval 4, interval 5, he pays $300 each. But then maybe it's like a loan repayment of some sort, right? Then you reconfigure the particular um, we reconfigure the particular cash flow so that he plays equivalent amounts in interval 1 and interval 2, and he pays equivalent amounts in interval 1 and interval 2, and equivalent amounts in interval 4 and interval 5. But does a skip, gets a holiday in interval 3. So what what would be this value C, so that in the end the same amount is repaid or received or whatever. Okay, all right. Okay, so how did we start off? We started looking at the left hand side. So we want to make these two equal. These two have to equal. So we started analyzing the one on the left hand side. So we label this. Let's label the value, the present value. So there's two ways to do that. There's two ways to do this. Either we compound all this period 1, 2, 3, 4, 5 and look at the future value in period 5, and we take these two C's, period 1, period 2, period 4 and period 5, and we compound it and we look at it at the future value point of view, and we try and equate those two together. Or we can roll it back. We can discount these $300. If you have a look over here, we can discount it, right? We can discount it, and get a present value. So what I did was I said, okay, let's discount it and roll it back into a present value. So what did we do? You see, the requirement is that when you these are two annuities. If you look at this two $100. Now remember, can I just ask you, what is the condition for annuity? There are two conditions whenever we talk about annuities. What is the condition number one? Anyone? Let's see, guys. What is the condition number one? First condition. First condition. Let's see if somebody wants to put in something into the chat box. Yes. Yeah. Okay. The first condition for annuity is, whenever we're talking about annuity, is that all the annuities are equal. Okay. So Tavake and Tepepe. Okay, that's correct. all annuities should be equal. What is the second condition? What is the second condition? The second condition is when you are talking about when you are converting from P to A or P to F, I mean A to F, or finding F given A, or when you are finding P given A, right? The condition is that that amount has to be, the P has to be immediately before the first annuity, right? So in this particular scenario, we are doing P given A, we are trying to find P given A, right? So that P is over here, all right? So what happens is that these two 100s we can roll it back, we can discount the two annuities, right? The effect of the effect of the two, the accumulated effect of the two annuities, but we will find the value of that present value immediately before the first interval, right? What about these 300s? We will find the effect when? Over here at number 2, at interval number 2. So then from 2 we have to discount it back to the first period. So what we did was we said, okay, there is P1A and P1B is at that point. Okay, P1A. Okay, so let me just put a note over here. Where is P1A? P1A is based at arises. P1A arises out of what? Let's see if somebody can answer. What does it arise out of? P1A. P1A arises out of, anyone? Come on, guys. Where does the P1A, what is contributing? What are the two contributing factors? I mean, what is contributing towards P1A? P1A arises out of, anyone want to put an answer over there? Yes, yes, yes. The 2 by $100, the 2 by $100 annuities from interval 1 and 2, right? Okay, and where does the P1B arise out of? The P1B arises, okay, and over here, where is P1A based? P1A is based where? Is based, where is it based? At 0, at interval 0. Why? Why is it? Why? Why? Well, because when we roll back A to find P, basically we want to find P given A, right? It will point, it will give P at the interval immediately before the first annuity. All right? Okay? All right? That's an important thing. All right? Okay, let's now look at this one here. P1B. Where does P1B arise out of? P1B. It arises out of the 3 by $300 annuities. Okay, and I'm just going to use some common language, but this is not professional language. I'm just going to say sitting on interval 3, 4, and 5. All right? Okay? And where is P1B based? P1B is based where? Is based at interval 2. And same reason. Why? 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 Because when we roll back A to find P, basically when we want to do A given P, when we want to do P given A, it will give P at the interval immediately before the first. In this case, 2 by 100, 2 by 100 annuities, right? 2 by 100 annuities. 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 2 by 100 annu at interval 2, since the first $300 is at interval 3. Okay, it's very important that you get this. All right, now, so that's why we have P1, which is the net effect, is the two coming in together. Now, what's P1C? Right, now what's P1C, by the way? What's P1C? Can somebody tell me where the hell did P1C come from? We know that P1A is from these two $100, right? We rolled it back to find it here, like what I wrote down. This $300 gave us the P1B, but where did the P1C come from? And the formula is talking about P1C. Can somebody tell me? Yes. You see, P1B is sitting at interval 2, right? P1C arises out of P1B, which is sitting on where? Sitting on interval 2, but it has to be discounted. Okay, I'm using the English term here, discounted. What is the technical term? What does discounted mean over here? What formula do we use? Right? Where it has to be discounted to interval 0. Right? Now, discounted means what? How do we do discounting, guys? We have to find P given F. Since our P1B becomes F when we look at it from the interval 0. Yeah? Right? And in the end, so we bring everything. So we brought our two $100 to interval 0 by rolling it back or discounting it, right? But it is an annuity. And this $300, we can only bring it here. So we have to do a further loop over here, and then we sum it up, the P1C and the P1B. So that's where that particular formula comes from. You've got to understand, it's not just a mathematical problem. You've got to understand what we have here. So this is what we did. After that, it's just simple. Once you've understood this diagram and you've reasoned and you've said, okay, this is what I'm going to do, then we go ahead and we just do some discounting, right? Okay, so P given A, P given A, and over here we had a P given F, right? Okay, and then eventually we found that that is the thing. All right, now let's look at the other side. Let's look at the other side. Let's look at the other side. We've got these two C's. All right, let's now see what we can do. All right. Okay, let me start up the thing over here. So let me draw a drawing. Red. Okay, that's my red. Okay, firstly, what we'll do is these two C's, right? These two C's, we can discount it. I mean, sorry, we are not discount. The word is not discount. We roll it back, or I'm not sure of the exact word. We roll it back to this particular point. We roll it back to this particular point. What do we get? If we roll it back to that particular point, let's call this P2A. Yeah, you see my notation. I'm using different alphabets. P2. Why P2? Because this was the second side. All right, so that's our P2A. Sorry. Okay, our P2A. That's sitting at interval 0. Now let's look at the other side. Let's look at this side here. We have another two C's over here, but they are at interval 4 and interval 5. And if we discount it, if we discount those two annuities, they will discount to which point? Which position, guys? Will they discount to position 0 or will they discount to position 3? Yes, they will discount to position 3. All right. Why? Why position 3? Because why position 3, guys? Well, because whenever you do a P given A, it discounts to the place immediately before. All right. So that will be, let's call that P2B. All right. Let's call that P2B. All right. Now, but that is not the end of the story. That is not the end of the story. All right. Okay. Now, sorry. Now, we want to take that P2B exactly in the same manner and bring it here, and that is our P2C, right? Of course, you can use some other notation if you want, but I'm just giving you different names for different variables. Okay? All right. There we are. All right. So, what is P2 equal to in the end? P2 will equal to P2A plus P2C. Right, let me just save this diagram, save this picture. Sorry. Please bear with me, I'm just using whatever tools I have at my disposal. All right, there we go, guys. Okay, nice and dandy. All right, now, so what is P2 equal to? P2 is equal to P2A plus P2C. All right. Okay, P2 is equals to P2A equals to P2C. Okay. Now let's go ahead and calculate our P2A. P2A. What is our P2A equal to, guys? P2A would equal to, what would we need to do over here? Okay, let me just copy this and they'll be very, very similar. Very, very similar. Okay. What is our P2A equal to? Okay, P2A will equal to, what do we need to do? We need to use P given A. All right. And maybe I should delete all this. All right, so that I give you guys a chance to get some exemptions. Okay, so what is the formula for P given A? How would we write it? How will we write this P given A? Well, we say our P2A is equal to, we have P, right? We have, sorry, we've got an A into P given A. P given A. Yes, thank you. Thank you. Who's that? Who's this guy? Amit. Very good. Right? And our number of intervals. Right? Okay. Now, this is the catch now. What is our value of A? Let's do the substitution. What is the value of A? The value of A is unknown. It's C, which we take as a variable. But for us as engineers, it's no big deal. It's no big deal for us as engineers. What is the I, guys? What is the I over here? I is how many percent? 12%. And what is the N? How many years are we discounting those two annuities? 2. Yeah, we bring it down by 2. All right. So let's now go ahead and calculate. P2A is equal to C 1 plus, all right, that's everything is the same, everything is the same. Can somebody tell me, as a function of C, what do we get over here? As a function of C. What do we get, guys, as a function of C? Is this formula correct? 1 plus... Yeah? Can you check that formula? Is that formula correct? All right. Now, what do we get as a function of C? Quickly, guys, quickly. As a function of C, you'll get some number. Something point, something, 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 and then the letter C. I'll write the letter C for you. 1.69. Can we give it in terms of 3 decimal places? 3 decimal places. So Amit, Josiah, and Ravi. 1.610. Oh, okay, 1.610. Okay, fair enough. All right, all right. I didn't realize that it was giving 1.610. Okay, let's do a P2B now. Same equation applies. Luckily, everything's same, right? Everything remains the same. P2B will get the same answer. Is that correct? P2B. Anybody disagrees with me that P2B is different? All right. Let's calculate P2C. P2C. Can you tell me what will we use for P2C? Yes. P given F. P given F. So P2C. Oh, thank you, Pranil. Pranil, you have caught on to something over here. Pranil is suggesting n equals 3. Pranil, can you explain what are you trying to say over here? No, Pranil, I think you made a mistake. We are only still going to, for P2C, P2B, yeah, it's still 2, still 2. Right. Still 2. All right. Okay. P2C will equal to, what will P2C equal to? We are trying to discount our P2B. So we will have our F into, we want to find our P given F, right? Can somebody correct me? What are we going to use over here? Are we going to use P given F, or what are we going to use over here, guys? P given F, right? P given F, and then we have our I% of N. And what is our F value over here, guys? Our F value is P2B, and we have P given F, comma, we still have 12%. What is the value of N this time? What is the value of N? When we want to discount our P2B all the way to the 0 interval. Yes, 3. All right. Now, P2C will equal to, see the formula, Okay. P2C will equal to, what do we get? What will come over here, guys? What will be on the numerator? On the denominator, yes, 1 plus 0.32, and then this answer is unknown right now. What we put on the numerator, guys? Can somebody tell me what will be on the numerator? Yes, yes, it'll be this guy, P2B, because that's what we were discounting. So therefore, what is our final answer? Is this correct? 3? Yes, 3. All right. What do we get in terms of C? Can you tell me in terms of C, what do we get? What answer do we get as a function of C? Come on. 1.203 C. All right. Now, okay. But we had earlier stated that P2 is equal to P1. What do we say? P, what was the formula earlier on? P2A plus P2C, right? What is P2A? What did we find P2A to be? 1.690. 690, right? Or is it 609? 690. Right. Okay. And what do we get? I hope all our calculations are correct. I'm not checking your answers. I'm just trusting whenever some 5 or 6 people have the same answer, I know that it must be correct. Okay. All right, 2.893C. That's our P2. Now, earlier on, one of the equations which we gave was we set that P1 is equal to P2. All right. P1, we had said that P1 is equals to P2. So, what is P1, guys? P1 is equal to, right? And that is equals to P2, which is equal to this guy. So therefore, simple mathematics, can you tell me what C is equal to? $256. I trust 3 or 4 people giving the same answer. So therefore, that is equals to that. All right? That's how you do this problem, guys. So in the end, what do we learn? When we look at this diagram over here, this equivalence basically is a way, of equating two cash flow diagrams to be the same. All right, two cash flow diagrams to be the same, given that there is something missing over here. And this actually happens in real life. It happens quite often. Okay. Okay, guys, any questions? Any questions? Any questions? No? No questions. Okay. All right, guys. Let's move on to the next concept. I want to introduce you to the next concept. We had spoken about annuity. Let us now speak about something called arithmetic gradient. That's another new concept altogether. So far, what have we learned? Let's now have a look at our particular thing. Let me just open up the Moodle shell. Hang on, let me stop sharing over here. Hang on. Stop sharing. Okay, let's go to the Moodle shell. I want to show you what have we done, what have we covered so far. By the way, guys, we will not be having face-to-face examination. All examinations shall be held online. Okay, right? They will be not in the beginning. You may remember that I had mentioned that I was trying to get students to sit a face-to-face examination at a campus closest to them, but my proposal for me, unfortunately, has been rejected. So you will sit a normal online examination on Moodle. So you've got to be ready for that. All right. We will also have a quiz shortly as well. All right. Let me just go to the week 8 section over here. If you click over here, you find. Oh, by the way, the new thing which I've shown over here is the playlist. If you click on this link here, it'll take you to the our engineering economics playlist. All right, formula sheet. Are you able to see the formula sheet? Can somebody confirm if you can see the formula sheet? All right. Now, if you look at this, f given p, we've done that. That was compounding, right? Compounding. P given f is discounting, right? Although over here, if you look at the factor name, the name of that factor, the name of this particular thing is single payment compound amount, single payment present worth, right? I usually use the word discount, all right? A given F, uniform series sinking fund, capital recovery, uniform series compound amount, uniform series present worth. We have completed all of this. We now move to present gradient, uniform gradient present worth, uniform gradient future worth, and uniform gradient uniform series. All right, the G. That's another new particular symbol known as the G. All right, and I will demonstrate this to you. And if you look at this formula sheet, that's your non-annual compounding, and you know these tables. The non-engineers, they use tables, but we usually just go ahead and apply the formula, and we get the exact value. All right. Okay. Let me just switch. Let me just switch back to the Microsoft Word document. Let me stop sharing, and then I'm going to reshare. I will be resharing my Microsoft Word document. Right? Can you see the Microsoft Word document, guys? Can you see that on screen? Can Hafiz and Bhavish, are you there? Okay. Now, let's look at this question. Now, you see, when we talk about annuities, if you look at the cash flow diagrams, right? An annuity is whenever you've got a straight line. Can you see this is a straight line over here, right? That's an annuity. What was the two conditions? That all the amounts would be equal, right? It would be equal. What's another one? Can you see this is an annuity? 3 annuities. These 3 amounts are equal, right? Can you see $440 a month? This is an annuity. All amounts are equal. Now, in gradient, whenever we are talking about gradient, right, arithmetic gradient, the amount increases by a particular amount, right? The amount increases. Okay, let's have a look at this question, and you'll start to understand and appreciate what I'm talking about. Suppose that a person buys a new car. Fair enough. The person wishes to set aside enough money in the bank account to pay the maintenance on the car for the first 5 years. The anticipated maintenance costs are: first year $120, second year $150, third year $180, fourth year $210, fifth year $240. All right, have a look at that thing. What do you notice, guys? What do you notice? We notice that, all right, there is a particular amount. So I'm going to start off the question, and then I'm going to yes, Upper Solomon. Yes, it increases by $30 every year. it increases by $30 every year. So I'm going to just go ahead and we will draw, based on that little table over there, we will draw the the cash flow diagram as usual. Our favorite diagram, okay, is the cash flow diagram. All right, so let's have a look at this. So we have there, all right, okay, 0, 1, 2, 3, 4, 5. All right, so we have 0, 1, 2, 3, 4, 5. Okay, all right. Now, what is this guy trying to do? He's trying to put away some money right away. He's trying to put some money right away so that, so that he can, so that money is already stored, right? He's trying to put some money straight away so that it will cater for all the future values, right? He's trying to put some money straight away so that it will cater for all the future values. Okay, all right, so that's our present value. He's trying to put some money away. What amount should he put away now, right? And let's now have a look at the amount of his expenses. Can somebody tell me what was the expense in the first year? It was, what is the projected expense in the first year, guys? What is the projected expense in the first year? Let's see it on the chat box. What do we get? 120. What is the projected expense in the second year? 150. Projected expense in the third year? 180. Then fourth year? 210. Fifth year? 240. Right? Now if you look at it properly, what do we notice? What do we notice? We notice that, well, it didn't come out all exactly perfect. If I was doing it with my hand, it would have been much neater. There we go. All right. So we have 120, right? And you're right. It's 120. Then there's 150. Then there's 180. Right? Then there's 210. Then 240. Okay, you're right, Terence. It's increasing by $30 every year. In this particular scenario, we apply the G, right? This is an arithmetic gradient, but there are some conditions. It's not straightforward. It's not straightforward like how we. It's not as straightforward like how we were doing annuity. There are some conditions as well. Remember, in annuity, you had some conditions to meet. You couldn't just apply it like that, right? Okay. So, let me. So this is the crux of the problem. This is the crux of the problem. Let me just save this. Okay, this is the crux of the problem. And I want to now introduce you, in order to move forward, I want to do a sample problem. I want to do a sample problem so that you guys have an idea of, of how to attack the gradient problem, all right? How to deal with arithmetic gradient. It's not as easy as it looks, okay? So let's now, before we move on to arithmetic gradient, before we attack the problem, we do a side example. Side example, all right? Let's do a side example. We've got to calculate our P given G. Now, there are some rules over here. There are some rules. Now, the first rule is that, the rule number one is that there are some rules, right? The first rule is that in order for G to occur, right? In order for G to flourish, the particular gradient, can you see that slope? We call it a gradient because there's a slope. The G has to start from 0 at interval 1. That is the catch over here, right? Yes, okay, G is linear, right? You're right, Amit, you're right. G is linear. It's supposed to be linear, right? There has to be a gradual and constant increase, right? You can't increase by $200 one round and then $300 another round, right? All right, it has to be linear, right? Has to be linear, right? And it has to gradually and constantly increase or decrease. It has to, okay, and it has to start from $0 at interval 1. These are the three rules, guys, right? So rules, not example. Right? Okay, how to calculate P or A or anything. How to calculate P or A or anything given G, right? Okay, now, so these are the rules, guys. Firstly, it's going to be linear. Can you see it's a straight line? When I say linear, it's not constant. There has to be a gradual and constant increase or decrease, right? And G has to start at $0 at interval 1. So that interval 1, it has got to be, that line has got to be at $0. All right, so let's now do a particular problem. Let's do a small problem, right? And I'll demonstrate what I'm trying to say over here, right? Whenever we draw something, then the life becomes easier after that. All right, okay, so let's do this. Okay, so there, okay, and the way the formula works, is, okay, that's 1, that's 10, okay, that's 1, 2, 3, right? Sorry guys, sorry, apologies. Okay. 0, 1, 9, 10. Okay, and we want to find P. We want to find P. We would like to find P. And the way G is, those formulas, the way they are rigged is that those formulas they go this way. Do you see what the catch is over here? What is the catch, guys? What is the catch here? Yes. Can you see it's $0, right? And let's give this some G of the G is the rate of increase. Let's say it increases by let's make it a nice figure, $250 per year, right? The G is $250 per year, which means it increases by $250 per year. All right, okay. So can you see it was $0 at year 1, right? $0 at year 1, $250 at year 2, right? So let me just so if you've got a G of that, what that means is that you have 250 over here, right? Then you have 500 over here, right? And who knows how much would you think you have, you know, by the time you reach the 10th interval. Can you see? So when you say G of 250 over here at year 1, the key thing is that that amount is 0. That amount is 0 at year 1. See what's happening? All right. Now how is this different? All right. Let's now go ahead and do a sample calculation for this, right? Before you know, we run out of time. Let's do a very quick sample calculation. All right, now let's calculate this thing here. Let's calculate. Let's calculate this, guys. What formula would we use to calculate this? We want to find P. So how can we find this P, guys? We will find with P given G. P given G. So what do? We have, how do we find P given G? Right? Now it's not that straightforward. What you have to do is you have to convert the G into an annuity. This is the catch, right? You have to convert, well, in fact, if you look at our formula sheet, there is a P given G, right? Let's go the first way. So we want to find P is equal to, we have G into P given G, comma, right? P given G. Then we have I at I%, right? And we have n intervals. And let's now go ahead and calculate this. Our G in this particular example was $250, and our particular P given G is the name of the formula, right? Our I, oh, I forgot to mention the I. Let us say, assume I is equal to 6.5%. Assume that I is equal to 6.5%, so 6.5%. And what is our N? Our N is 10 intervals. What do we get, guys? I give you some time. Let's quickly calculate what is our P over here. What formula do we have to refer to? We have to refer to the P given G formula. Anyone? What answer do you get? The P given G, the P given G formula is available where? It's available in the formula sheet. Anyone? What do we get, guys? What do we get? That is the formula. That is the formula. Anyone? What do we get? What answer do we get? Let's finish up our lecture for today by getting the answer for what is the P given this particular scenario, for this particular example. Does anyone have an answer? I just created this problem right on the spot, guys, so I don't have the answer with you with me right now. Anyone wants to get that exemption? All right, let's see. All right, Amit is saying that it's $110. Can't be $110. Okay, Amit is saying that it's $110. Something is wrong here. All right, we'll have to have a look at it. I'll just put this in red. It has to be much greater because the first thing is 250. Anyone else? Anyone else got something different? All right, guys. We'll stop there for today. We'll stop the lesson for today because we've sort of run out of time. We'll again continue this particular problem. And remember, we haven't done this problem. The main problem was this problem. Salome is saying 1.6 million. Oh, no, I think Salome, that's too much again. I'll try and see what the answer is. But I'm giving you a chance to have a look at that as well, all right? Okay. This answer, 110, I'm not sure. Maybe it's wrong. It's wrong. And also the other answer from Salome is saying that it's 1615 million. I think that's a bit too much as well. Both is incorrect. Okay. Anyone? Last chance? Alright, guys. We'll stop the lesson for this afternoon. Thank you so much for attending. We will continue tomorrow. We have not finished the particular exercise. This exercise is still pending. Remember, I was just showing you how to apply the P given G rule. Alright? Okay. That's it for this afternoon. Thank you for attending, and we'll see you in tomorrow's lecture. Goodbye.